guys, welcome to my YouTube channel. Today I'm going to help you with how to find speed in knot and kilometers per hour along the Earth's surface. As you can remember, the way we did in our linear motion, we said that distance is equals to given by speed multiplied by time taken. So it means that speed is given by the distance over time taken. This we did it in our previous video. You can click on the link up here to check it out. So you're going to begin by, but there's some things you also have to know. Knot is equivalent to distance in nautical miles divided by time taken. Are we together? So that is knot. So that's our formula. Our speed, it's distance in kilometers over hours. This is distance in nautical miles over time taken in hours. So there we have the two formulas. So you're going to rotate around those two formulas. So to begin with, you're going to start with this example that a plane flew from A to B along the parallel longitudes and took 2 hours. It then took a 2-minute rest and flew to town C, where it took 1 hour to arrive to town C. So the first question, they've said A, find the speed in kilometers per hour, and B, find the speed in knot from A to B and from B to C. So there we have it. We're going to calculate the speed in knot between A and B and from B and C. So we have our towns here. So town A is located at that place, which is 45 degrees to the north and 15 degrees to the 30 degrees to the west. And then B, it's on 45 degrees to the north and 15 degrees to the east. And then we have our C, which is 60 degrees to the south and 15 degrees to the east. So we are told to calculate the speed in kilometers per hour and in knot from A to B. So we're going to first find the angle difference. So for the A and B, they said along the parallel lines. We're not going to use the shortest distance, so we're going to use along the parallel. So the angle difference between A and B, we're going to begin from there to find the distance between A and B. Then we find the speed it took. So the distance between A and B, we're going to find the angle difference. So A and B. So first, the angle difference in A and B. The angle difference between A and B. So A is located at 30 degrees to the west plus 15 degrees to the east. So this is equivalent to 45 degrees. 45 degrees. So we have our angle difference. So first, you're going to find the distance in kilometers. So remember, this is along the small circle. So we say the formula for small circle is going to get in kilometers is given by angle difference over 360 2 pi r cosine r, radius of the earth, cosine that latitude. So between A and B in kilometers distance, it will be our angle difference, which is 45 divided by 360 times 2 times 22 over 7 times 6,370 kilometers cosine that latitude. Our latitude is, come here at this table, our latitude is marked, you can see our latitude is marked 45, so cosine 45. When you press this on a calculator, it's going to give you 3,539.06944. So into the nearest kilometer, it will be 3539.0 kilometers. So that is the distance between town A and B in kilometers. What about the distance between town A and B in nautical miles? So you're going to calculate it just here between A and B in nautical miles. So this is equivalent to, we say the formula for finding distance in small circle in nautical mile, we say it is equals to 60 degrees multiplied by angle difference times cosine that latitude. Are we together? Cosine that latitude. Cosine that latitude. So this will give us 60 multiplied by angle difference. We said it's 45. So this is equivalent to 45 times cosine that latitude. That latitude again, it's what? From here. Our latitude is 45. So you're going to get 45. So when you do this on a calculator, you're going to get 1909.18830. So into nearest nautical miles, it will be 1909.0 nautical miles. So there you have it. We are halfway the question. So first we found the distance in nautical miles between these 2 points. So you're going to find the speeds in these towns. Okay, when I take you back to our question, they said it took 2 hours from A to B. So when coming back to this, we said it took only 2 hours from A to B. It only took hours. So we've said the speed is given by distance in kilometers over time in hours. So this is going to be our distance, which was 3,539 divided by 2 hours, and the knot we said is distance in nautical miles over our time in hours, which is equivalent to our distance in nautical miles here, 1,909 over 2 hours. When you do the first part in the calculator, it's going to give us 1,769.5 kilometers per hour, and in knot is going to give us what? 1,000. It's going to give us 954.5 knots, or nautical miles per hour, or nautical miles per hour. So there we have it. We are done with the first section, finding the distance between A and B in nautical miles. I can pause the video and then check the whole calculation up to the end before we move to the speed in knot and kilometers from B to C. So we're moving to our second part, which is the distance. We've told that it took 1 hour from B to C, which is the distance along a great circle. Reason being, it's along a longitude, and we said all longitude and the equator are great circle. So remember the distance in great circle in kilometers. So distance in kilometers in great circle is given by angle difference over 360 times 2 pi r, and then in nautical miles is given by 60 times angle difference. Are we together? That's we have it. But first we're going to find our angle difference. Our angle difference, you can see that B is located at 45 degrees to the north, and C it's at 15 degrees to the it's at 60 degrees to the south. So it means that the angle difference will be 45 degrees to the north added to 60 degrees to the south. We are adding because they are on different hemisphere, and with this we said when they are on different hemisphere we add, when they are on the same hemisphere we subtract. You can check this on our video that we did on location of places on the earth. So 45 plus 60 is going to give us 105 degrees. So we have our angle difference. So first, finding the distance in kilometers, it's going to give us, we're going to use this formula. It will be 105 over 360 times 2 times 22 over 7 times 63, 70. When you press this on a calculator, it's going to give us, 11,678.333 recurring. This is equivalent to 11,678 kilometers. Are we together? And then you're going to work on nautical miles. In nautical miles, we're going to use this formula. So this formula is going to give us, which is 60 times angle difference. So in nautical miles, we know that this is 60 times 105. So 60 times 105 is going to give us 6,300 nautical miles. So there we have it. We have our two distance. One is in kilometer and the other one is in nautical mile. So you can pause the video and then check before we move to our speed, which is the question that we've been asked. We know that speed is given by distance in kilometers over time taken in hours. At the same time, the knot is given by distance in nautical miles over time taken in hours. So when we know that our distance in kilometers is 11,678 kilometers, so this will be 11,678 kilometers divided by, we've been told it took 1 hour. So our speed, it will be 11,678 kilometers per hour. So the knot is going to be, our distance in knot is here, it's 6,300 nautical miles divided by 1 hour. This is equivalent to 6,300 knots. So there you have it. You can check it from above how you've done it. The distance between B and C. So this was distance between B and C, and we have arrived to that answer. Two airport A and B are located on the Earth's surface at the following coordinates. So A is 40 degrees south and 40 degrees to the east, and B is 30 degrees to the north and 40 degrees to the east. B, calculate the shortest distance between A and B in nautical miles and in kilometers to the nearest kilometers. And C, a pilot flew from A to B in 8 hours. Calculate the speed in knot and in kilometers per hour correct to the nearest whole number. So to begin with, we're going to find the latitude difference. I'm going to plot for you, but it's not a must for you to plot if you have the idea, but I'm going to plot for you so that you get the concept of getting the latitude difference. So to start, so they say that A is 80 degrees to the south and 40 degrees to the east. So we are going to begin from here. I've drawn for you. So we are going to locate A, 10 degrees to the south and 40 degrees to the east. So 10 degrees to the south is found somewhere here, 10 degrees to the south of the equator. And then we have 40 degrees to the east. So this is our 40 degrees to the east of the Greenwich meridian. So we have our town A here. What about town B? Town B is equals to 30 degrees to the north. So it will be around here, 30 degrees to the north, and then 40 degrees to the east. So along this latitude. So we have our B here. You can see B and A, they are located on the same longitude, and that longitude is 40 degrees to the east of the Greenwich meridian. So because they are on different hemisphere, B it's on the northern hemisphere and A it's on the southern hemisphere, we're going to add there for us to get the angle difference. So for A, angle difference is going to be given by, the upper one is 30 degrees north plus 10 degrees south. This is going to give us 40 degrees. We're done with the first part, adding the angles because one is on the northern and the other one is from the southern. So B, calculate the shortest distance between A and B in nautical miles and in kilometers and in the nearest kilometers. Remember the first formula we said, distance in nautical mile in great circle is given by 60 times angle difference. So this is in nautical miles, it will be 60 times 40. So 60 times 40 is going to give us 2,400 nautical miles. So you're going to calculate distance in kilometers, which is given by angle difference over 360 times 2 pi r. This is equivalent to our angle difference we've said is what? 40. So this will be 40 over 360 times 2 times 22 over 7 times 63, 70. This when you do in a calculator, you're going to get, this when you do in a calculator is going to give you 4,449. 4,449. So that's, we've round off to the nearest kilometers. And then you're going to move to our section C. We've been told a pilot flew from A to B in 8 hours. Calculate the speed in knot. So we know the speed is in knot is given by, and knots is given by distance in nautical miles over time in hours. Are we together? So our distance we've said here in nautical miles, our distance in nautical miles was 2,400. So it's 2,400 nautical miles divided by how many hours? It took 8 hours as per the question. 8 hours. So 2,400 divided by 8 hours is going to give us, this is going to give us 300 knots. So that is speed in knots. So you're going to move to speed in kilometers per hour. Speed in kilometers per hour. This is given by distance in kilometers. Our distance in kilometer is 4,449 kilometers. So it's 4,449 kilometers divided by 8 hours. So this will give us 556. This will give us 556.125 kilometers per hour. This, when you round off to the nearest kilometers per hour, it will be 5,000. It will be 556 kilometers per hour. So there we have it. So we have the So there you have it. That is the whole calculation from the start up to the end. So you can pause the video and check. So that marks the end of our speed in knot and distance in kilometers and speed in kilometers per hour. So thank you for watching and stay tuned for next video, and don't forget to click the subscription button. Thank you.